Hello class, so in this video we're going to be talking about domain and range. So before beginning, I'm just going to say a quick thing. This is a very simple concept, but also very easy to overthink because of how simple it is. So if you feel yourself overcomplicating it as you go through this, just pause the video, rewind it, process it, whatever you need to in order to understand the basics, and then move on. Alright, so let's just recall what a function does in the first place. That's kind of the basis of domain and range. So a function, in its most technical term, is a mapping of elements of a set X to elements of a set Y. So what in the world does that mean? That means that you have a set called X, and you have a set called Y. What does f of X do? It takes things from X and brings them into Y. So there's a way where X is turned into Y's basically. So what that means is there's a relationship where something happens to X values and then they become a Y value. So for instance, in f of X equals X squared plus 1, if we put some number into f of X, then the function is just going to square that number and add 1 to it. That's the something that happens. And the result is going to be that Y value. So you put in an X, you get a Y after things happen to it. So let's just go in with the definitions then. So the definition of domain is the set of possible inputs. The definition of range is the set of possible outputs. So essentially, if we look at this set over here, X represents domain. The set X represents domain. Don't just think that all of the X values are domain, or that domain is the X. That doesn't actually make any sense whatsoever linguistically. So Y values do have to do with range, X values do have to do with domain, but listen very carefully and go through this video very carefully as well. Don't oversimplify, don't overcomplicate. So the first question is, how do we even find them then? Let's analyze definitions. That is going to be the main thing that's going to help us understand this then. The domain of a function is the set of possible inputs. So the question is, what does possible mean? Well, that could also lend itself then to, what does it not possible mean? So not possible simply just means this word, undefined. Undefined essentially just means does not make sense. So an alternate, more maybe useful definition is a set of inputs that makes the function not undefined, that do not make the function undefined. So let's just go through this and see how that goes. So let's find the domain. Essentially what we're going to do is figure out, is the function undefined at any point? If it is not, then we don't have to worry about it, we're good. If it is, then that's when we have to figure out, okay, so we have to remove those points, and then the rest of that is the domain. So let's look at this. F of X equals X squared plus 2X minus 1. Is there anything that's going to make this undefined? Well, it's not dividing by 0. You're not doing a negative log. You're not doing a negative square root. You're not doing a 0 log, so looks fine. So that means you can write the domain for this as that, all real numbers. Or this. So this is set notation. I have a separate video that talks about this if you need to look at that. This is also one of the more familiar forms to write it in. And here is the interval notation version of that. So all 4 of these say the exact same thing. Alright, let's look over here then. Log of X minus 1. So again, I'm just going to illustrate real quickly. Imagine you have this set. This set represents all real numbers. Let's just say there is a subset which tells you what is undefined. So if we don't include this at all, the rest of it is the domain. So let's figure out here, is there anything that's going to be in that undefined part or not? So for logs, the inside must be greater than 0. So x minus 1 has to be greater than 0. That means x has to be greater than 1. That means that if you put in anything that is 1 or less, you're going to get an undefined value from the logarithm. So the domain is, you can actually write it like that. X is greater than 1. Or you can write it as the domain is 1 to infinity, or in set notation, x such that x is greater than 1. Again, they mean all the same thing. So in this case, this little undefined section is going to be x is less than or equal to 1. All of those x values. All right, let's look here then. H of t equals t minus 2 over t minus 1. Is there anything that's going to make this undefined? Well, in this case, undefined would just be dividing by 0. So t equals 1 is going to make this 0, right? That's pretty clear. So if we look at that little diagram again, the undefined part, t equals 1. So if we remove 1 within all the real numbers, then the rest is the domain. So easiest way I would say to write this is just all t's such that t is not equal to 1. You can also write it as negative infinity less than t less than 1. 1 is less than t is less than infinity. Or the interval notation version of that. They both mean the same thing. Also means the same thing as that. All right. Now let's look at the range. So the range is all possible outputs, and it is, again, a set. So we can see the outputs pretty easily through a graph. If we know the parent functions, that also helps as well if we have transformations. However, what if we don't know the graph? Well, we can always use the domain, actually, because as we just saw above, domain is actually not too difficult to find. With some functions, what you can do is actually find the domain of the inverse. So look at this. X goes to y with a function f of x. We can take a y value and go backwards with f inverse of x. That's what inverse means, right? So notice that that function goes from y into x. So if we find the domain of that function, we will actually find the range of f, because the domain of that function is the place where f goes into. So that's interesting. So let's try doing that and graphs and see how this works. Alright, so let's find the range. This thing. There are a few ways that we can do this. One way is graphing. We know that that's going to be at -1. So this is a parabola shifted down 1 unit. So that's going to be at -1. Goes up like that. So the range, you can say, is y is greater than or equal to -1. Or interval notation version. Or this set notation version. Again, they all mean the same thing. Well, how about this thing? Well, we know that the parent graph looks like this. How is this thing transformed? So this thing is moved to the left by 1 unit. To the right by 1 unit, sorry. So it's going to be this same shape, except it'll just be moved over by a unit to the right. So something like that. But does that change anything with the y values? No. We know that this thing goes between -infinity to infinity anyway, so could just be -infinity is less than y is less than infinity. If you use this version, make sure you use y, don't use x. Or interval notation version, or set notation version, you can just say this. You can also put that thing inside there too, but that's a bit long if you're going to write this. All right, so now let's look at the range for this thing. That'll be interesting. So at first it's not exactly obvious what this is going to look like. You could graph this real quickly and do the same thing, but we don't need to do that. We can also do the other thing that I mentioned. So let's find the inverse and then find the domain of the inverse. Okay, so t equals y minus 2. So essentially the strategy for finding an inverse, flip the x and y, in this case x is t, and then just solve for y. Alright, so we get, if we multiply y minus 1 to both sides, that will divide out, and we get ty minus t equals y minus 2. Alright, get all the y's on one side, ty minus y equals t minus 2. Factor out a y. T minus 1 equals t minus 2. Divide. So we get y equals t minus 2 over t minus 1. So conveniently, they're actually the same thing. So if we find the domain of this, and this is actually the inverse, then we'll find the range of the original. So the domain of this is just all t's such that t is not equal to 1. So that means the range of h, so this is the domain of h inverse. So the range of h is then just going to be all y values such that y is not equal to 1. So we can get that way. Alright, so that's going to be the end of this. Hope that was helpful, and I will see you in the next video.